equation like the absolute value of x equals 2. What does this say to me? This says, literally, find x such that the distance between x and 0, because this is basically this. This is the distance between x and 0. Distance between x and 0. Find x such that the distance between x and 0 is 2, or 2 units if you want. So let's look at it on the real line. Here's 0. And tell me how many numbers have the distance from 0 exactly 2 units?
2.
Yes. Yes, I'm sure you're going to say negative 2. Oh, the pink. Sorry. Negative 2 and positive 2. And see why this equation has x equals plus or minus 2. Plus or minus come from the absolute value. There are several possibilities here. Actually 4. 4 possibilities. 4 possibilities. When solving absolute value equations, as the answer. 1 solution, 2 solutions, no solutions, infinitely many. These are not linear equations. You can say, oh, it's a linear. No, it's not. Look at the options. 1 solution, no solutions, 2 solutions, and infinitely many solutions. So I showed you the example with 2 solutions. That is done. Let me show you an example with 1 solution. The absolute value of x equals 0. This one has only 1 solution. Just x equals 0. There is nothing else. What can I put in here so that the absolute value is 0? Just 0. I can't put anything else in there. So this is just 1 solution. Now let's look at the possibility of with no solutions. The absolute value of x minus 3 equals negative 2. There is nothing. This is a distance. This is always a positive number, and this is a negative number. A positive number cannot equal a negative number. Done. No solutions. Not possible. So we've seen the first 3 options. Let's see the last one. When an absolute value equation can have infinitely many solutions. Any questions so far? Please stop me, please. So here's the one example. Your book does not present any absolute value equations. I haven't seen any absolute value equation with 2, so you will not be tested on this. I just want to show you an example. You can disregard it if you want to. So this situation has still only 2 options. X minus 1 to equal 1 minus x, and the other one with a minus. Minus 1 minus x. Exactly like we had here. Although this procedure will not work for 3 absolute values, but it's not part of this class. So, see, plus or minus, the other side. So I have the plus of the other side and the minus of the other side. So when I solve this equation, I bring, let me write it again. X minus 1 equals 1 minus x. I bring negative x, it becomes positive, so then I have 2x. And I bring negative 1, and it becomes 2, and when I divide by 2, I get x equals 1. But when I solve this one, here's what happens. X minus 1 equals negative 1 plus x. I will add 1 to both sides. I will subtract x from both sides, and I get 0 equals 0. We discussed that a long time ago. It's an identity. How many solutions does an identity have?
Infinite.
Infinitely many solutions. So 1 is included in the infinite. I don't have to write it again. You don't have to cross it out. It's correct. But infinitely many solutions, 1 will be included. So the point I'm making with this is that absolute value equations are a special type. Look how many different situations we encountered. You will not encounter this one in this class. I just wanted to show you. And you will not be tested on something it's not in the book. Okay, moving on to quadratic in form. So going back for a second, let's see. I think we have only one more left. Yes. Absolute value done, quadratic in form, and then equations with rational exponents is the last one. Quadratic in form. Okay, I'm going to copy a problem. They are from 41 through 60 on page 185, 186. Okay. I'm going to choose a simple one to start with. Let's say 42. Like before, it's established from the very beginning. What is the degree?
4.
Very good. Which means how many solutions?
4.
And now you're going to say, what are you talking about quadratic in form? This is polynomial. What is all that? It's a polynomial equation, degree 4, 4 solutions. What are you talking about? True. It is also a polynomial equation. But this is a polynomial equation that can be changed into a quadratic. This one that we started with when we looked at polynomial equations, we could have not ever changed that equation into a quadratic. We cannot change this equation to a quadratic. We cannot change this equation into a quadratic. So, although this belongs to the category of polynomial, it's a special category in which I can change it into a quadratic equation. How do I do that? And how do I know even that it can be changed into a quadratic equation? I don't. I'm going to analyze it. I see the two terms that have x. This one has x squared, and this one has x to the 4th. And there is no other x anywhere. Because if there is this term with x, it's not quadratic in form. So I see a term with x squared and a term with x to the 4th. The one with the smallest power, I'm going to denote it by another letter. Give me any other letter, not x. Any letter you want, but not x.
Y.
Y is perfect. If I denote this by y, what will this become?
Y squared.
Indeed. And that's my answer. So that's why this is a quadratic in form type of equation. Because I can replace this by y squared minus 13y, this y, plus 36. If I cannot replace it using a different letter, you can also consider this a procedure substitution. I am substituting x squared by y. Therefore, I have to substitute x to the 4th by y squared. I cannot have x and y in the same problem. Now, I know how to solve this. It's quadratic, and it's factorable. I need the blink. Y minus 4, y minus 9. I get two solutions in y. Can anyone give us the solutions in y?
Y equals 4 and y equals 9.
Excellent. But now these two are two new equations that I have to solve. When I say y equals 4, I really mean x squared equals 4. When I write y equals 9, I really mean x squared equals 9. Why do I go back to x? I have no choice. I have to present 4 solutions, and they have to refer to x, not to y. Nobody cares about y. We do because it helped us solve the equation. But we cannot leave the answer in y because the equation is in x. So, which method is applicable here out of those 4? Very important. It's one that is very easy. Square root indeed. But if I forget to write plus or minus, I will not solve the equation correctly. That's why from the very beginning I wrote myself a note. Don't forget, it's degree 4. You must come up with 4 solutions. If I don't write that, who knows? I may forget. These are equations quadratic in form, and I think we should practice a little more. How do you feel about this?
Doesn't seem legal.
It does not seem legal? Okay.
Basically, it looks like you just made a new equation.
Sure.
What
To
about
make
x?
to make my life easier. Why not?
I guess. But what about the x to the 4th? Like, what's up with that?
You want to check the solutions? I cannot change the equation. I cannot change x to the 4th. You want to change it? You want to check the solutions? You have any doubts? Okay.
I don't know.
Okay, let's take a look. Very good point. So let's go to y equals, clear everything you have, and plug in x to the 4th. Let's do that. It's a very good point. Very good point you're making. You should not believe anything.
Thank you.
I agree. You have to say, prove it. Awesome. Let's go back to second and table. And let's plug in. 2 enter, negative 2 enter, 3 enter, negative 3 enter. We see the result for all those 4 solutions?
So 0 for all of it.
As it should be.
I see.
As it should
But
be.
mine's 2 and 3. And that's some mathematician type stuff right there.
Good. Good. I'm very proud of you for asking. Great job. Let's look at another. This is a very neat procedure called substitution, or if you want, they are quadratic in form, applicable specifically to those equations that can be changed into a quadratic, solve this a quadratic, and then go back to the original variable. Specific type.
So my question
Please.
is, how do you know?
I don't. I have to look at these powers. I have to look at these powers and see if I can replace this by y and this by y squared, or t and t squared. If I cannot, it's not quadratic in form, and this procedure is not going to work. Very good.
So for this equation, or I should say for the first equation that we did for polynomials, because it had an x to the 3rd power, it wasn't quadratic in form.
It was not quadratic because, first of all, a quadratic equation has to have 3 terms. No quadratic equation has 4 terms. No quadratic equation has 2 terms.
Right.
So that was the first thing. And secondly, the powers did not match. So if I have here power 3 and here I have power 6, it works. Because x to the third, if I denote it by t, then this x to the 6 becomes t squared. As long as I can have, it's a very good question, as long as I have a quantity that I can replace by t and the other one by t squared, and there is nothing else, I can go ahead.
Awesome. I like this. This one's fun.
It is fun, and it's specifically for specific situations. You cannot apply it just any time. You could say others, in my other classes, for example, a student says, oh, I can see how to factor this. What are you talking about? I'm not going to use your substitution because it's very clear to me this is x squared minus 9 and x squared minus 4. Hey, I don't care for your substitution because I know that this is x plus 3, x minus 3, and this is x plus 2, and x minus 2 equals 0. And I'll say, fine, if you see that, awesome. And then you have all those 4 solutions in a blink. Fine. The method is useful to know it. Now, if you can see that this factors x squared minus 9, x squared minus 4, and you factor completely and you get the 4 solutions, I'm fine. No one is going to force you to use substitution. But substitution is supposed to make our life easier when we don't see how to factor this directly. But as I said, I had other students who said, no, I'm not, for this problem, maybe for others, but for this one, I know that. Fine. Great job. Okay, so let's take a look at another, like 57 caught my eye. Same page, 185. So x squared minus x, everything squared, minus 14, x squared minus x plus 24 equals 0. You can say, just expand all this and see what happens. True, it's very possible. But I have x to the 4th, right? When I square x squared, I have x to the 4th. Definitely degree is 4, and I have to come up with 4 solutions. So, by simply looking and inspecting, just inspecting the equation, just look at it, you should be able to say, okay, I see. If I denote this by t, this piece is definitely t squared. So my equation is t squared minus 14t plus 24 equals 0. By letting t be x squared minus x. Or you can say, I don't care for your method. I'm going to expand and see what happens. That's fine. I like to practice the method of substitution because this equation is quadratic in form. If with an appropriate substitution, I can change it into a quadratic equation. And why not? This is a blink. This is t minus 2 and t minus 12. It can be easier. Why go through the time-consuming, expanding, distributing, combining like terms, and then I get a polynomial degree 4. I may not even know what to do with it. When this is so much easier, I change it into a quadratic, I solve for t. Yes, this is not enough. I'm not done. Because now this equation becomes blah, 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 because t is x squared minus x equals 2, and this equation becomes x squared minus x equals 12. But these are again 2 quadratic equations which I mastered already last week, so it shouldn't be a big deal. Move 2, move 12, and solve them. And make sure I get 4 solutions. So then I have x squared minus x minus 2 equals 0, the first one, and x squared minus x minus 12, the second one. And this is quadratic. I don't have to deal with a 4th degree that I may not even know what to do with. So this is x minus 2 and x plus 1. And I get to a negative 1, and it's done. And this is x minus 4 and x plus 3. I get 4 and negative 3. And here are my 4 solutions. So the method is very useful. In certain situations, if you have an easier method, use it. That's perfectly all right. I know we only have 3 minutes left, but I'd like you to do one problem now. Let's say 56. And then we'll stop. I'm ready for questions, please. Always. I'm always ready for questions. So let's work on this, and then we'll stop. And then I'll make another quiz for Thursday. You do not have to use substitution. This is an easier situation. It's quadratic. But use substitution just to see what happens here.